So the first conic section that we're going to look at is the circle, and it's pretty cool how the equation for the circle is derived. So we've got this example for a circle where the center is HK in the coordinate plane, and then our radius is R. So we're just looking at a generic circle. That point that we touch on the circle is just any XY value. Okay, so we could represent the length of that radius using the distance formula. So remember that the distance formula has this x2 minus x1, y2 minus y1. So if instead of just saying the distance equals this, we can say the radius equals this. And then instead of just using my x2 and x1, I can actually talk about the x values that I'm using. So I'm using an x value of h, and then my x value here was just a generic x. So I'm going to go ahead and say x minus h would be that distance between them. Same thing with the y's. If I'm subtracting my y1 minus y2, I can do y minus k. Or y2 minus y1. Really doesn't matter. So I've got my x minus h, y minus k, and this is pretty much the equation for a circle. The only difference is that we typically square both sides, so that we're looking at radius squared equals this x minus h squared plus y minus k squared. So if you were given the equation, maybe x minus 3 squared plus y plus 2 squared equals 16, something like that, then we could say, okay, because we're already subtracting here, we're always going to take the opposite of the sign. So that means that my x had to have been a 3 for the center. My y, since I changed from negative to positive, that means that my y had to be a negative 2. So that's always going to be the opposite of the sign. Positive 3, negative 2. And then to find my radius, since my radius up here was actually my radius squared is what it's equal to, that means I just have to take the square root of that to end up with what my radius is. So this equation literally says this is giving all of the xy coordinates that are exactly 4 units from the center. Same thing with my generic. It's telling me these are all the x and y coordinates that are exactly r units from HK. So let's go through a few examples here. Looking at number 1, we're trying to identify the center and the radius. So remember, your center is going to be that number, that x minus h, y minus k, but it's always going to be the opposite. So for our center, our x value is going to be a negative 15, our y is going to be a positive 13. And then for the radius, we're always taking that number that it's equal to and taking the square root, because remember, that piece right there is the radius squared. Okay, for number 2, I'll have 0, since I subtracted 0 there, 15. And my radius, if I take the square root of 1, I just get 1. Okay, go ahead and pause the video, try 3 and 4 on your own. So for number 3, you should get a center at negative 6, negative 15, and a radius of 2. On number 4, you should get a center of negative 2, negative 9, and then a radius of radical 72. And with that radical 72, it kind of depends on what we're trying to do with that. Whether we leave it radical 72, we could simplify it radical-wise to where we have, let's see, this 36 times 2, so 6 radical 2. Would be the simplified version. If I'm trying to graph this equation, then I probably want to go ahead and get the decimal approximation for radical 72, so that when I'm plotting those radii and making sure that it's that distance from the center, I would actually, let's see, radical 72 is about 8.5. So I would know I'm about 8.5 from the center in all directions. So it kind of depends what you're doing, where you would leave that. So now let's look at graphing a few of these, and you don't have to actually have graph paper in order to graph them. So as long as you just give yourself a little coordinate plane, a sketch of this is fine to give you an idea of what's happening. First, we do want to identify that the center here is going to be a negative 3, negative 4. So we would go ahead and plot that. -3, -4 as best you can. And then we're taking the fact that the radius is 2. And I can't really count 2 in like a diagonal direction from the center, but there are certain directions that I can count 2. So I'm just going to go those directions. So I can count 2 up. I can count 2 down from the center. Oh, that was 3, wasn't it? Ew, no. That's not too bad. Okay, there's my 2 down. I can count 2 to the right and 2 to the left. And that's going to give me a pretty good idea of what my circle looks like. So from there, I'm just going to sketch it. Okay, so not perfect, but that gives me a pretty good idea of what this circle would look like on the coordinate plane. For number 6, you might already notice that 8 is not a perfect square, so this one is going to be a little bit different just in that radius piece. But I'm still going to start with my center, that I would have a center at 1, -4. So there's my center. And then for my radius, I want to go ahead and take the square root of 8, and this is kind of what I was talking about with number 4 up there, that if I'm going to sketch this square root of 8 up, down, left, and right, I need an approximation for that, and the square root of 8 is about 2.8. So it's not going to be quite 3 from the center, but very close, especially since I'm using a marker. So my up and down, I'm going up about 2.8, down about 2.8, right about 2.8, and left about 2.8. Again, not perfect, but gives us an idea of what this is going to look like. So for our last 4 examples, we're going to be writing an equation for each one of these. So kind of working backwards. If you need to, you can look at one of these equations up here to kind of help you out. But for that center, I know I'm going to have x minus that x value, so x plus 12 squared, plus my y minus 12, so y plus 12 squared. And then it always is going to equal my radius squared. So since I have 4 squared, it will be equal to 16. Okay, same thing with number 8. I've got an x minus -8, y minus -1. And then what's nice about this is that it looks messy to have radical 22, but when I put it in my equation, it's that radius squared. So when I square the square root of 22, I'm just going to get 22. So for these last 2, I first just want to identify in my graph the same information that they gave me on 7 and 8. So I'll go ahead and plot that point for the center and just see that that point is at 2, -4. So that's my center. And then counting up, down, right, or left from the center, I should get the same thing every time, and it looks like a distance of 1. Be very careful on this to make sure that they're actually counting by what you think they're counting by, because for this one, those 2 marks actually is only 1 instead of 2. So be careful. The radius is 1. So doing the same thing that I did on number 7, I've got my x minus 2 squared plus y minus a -4, so plus 4 squared equals my radius squared, just 1. Okay. Go ahead and pause the video, see if you can write an equation for number 10 on your own. So over here is what you should have gotten for the center and the radius. Again, making sure that you're counting by the right units, so it went from -3 to -1, so that radius is just 2. And then your equation should say x plus 3 squared plus y plus 3 squared equals 4.